Before we get started with the material for today, I want you to notice that the essential question is the exact same essential question for today as it was yesterday. That means that after you get done with this lesson today, that doesn't mean you don't have to write a summary. What it does mean is you should go back to yesterday's summary and add to it. And by all means, if you have not yet written your summary from yesterday, go ahead and make sure you get it written and get it well written, adding in information from today. So we're going to take a look today at more solving systems equations by graphing. These ones are going to be a little bit more difficult when we talk about solving, because we will have to solve for y every time and talk about some special systems of equations. So we're going to take a look at this first example here. And this first equation, we want to solve the system by graphing and then identify the type. So we have here 2x plus y equals 8 and negative x plus 2y equals 1. So our first is going to be to put the equations into y equals mx plus b form. So I'm going to start off by taking my first equation right here, and I'm going to do the work over here for it today since I don't have a lot of space that I've given myself. 2x plus y equals 8. So I'm first going to subtract 2x from both sides, giving me y equals, make sure you put it into standard form, 2x plus 8. Then I'll go ahead and take my blue equation, and we've got negative x plus 2y equals 1. Now before I go ahead and solve that, I'm going to go ahead and do what step 2 reads, which is to graph. So then that way we can have it already taken care of. So y equals negative 2x plus 8. I'm going to go up 8 on the y-axis, and then negative 2 means to go down 2, forward 1. Remember, we're getting in the habit of graphing all the way across the graph, and as well as going backwards. So I'm going to go ahead and connect my dots, and then I'll switch over now to my blue graph. I'm going to start by adding x to both sides to give me 2y equals x plus 1. Then I'm going to divide by 2 everywhere, and that gives me y equals 1/2, because remember this is 1x, so 1/2 x plus 1/2. So this one's a little more difficult because we're crossing at positive 1/2, which isn't quite there, and then we've got up 1, forward 2. Now remember, we're never going to be quite on the ordered pairs. So up 1, forward 2, up 1, forward 2, and I see that I'm already going to cross. So in this case, I don't have to draw every single one of those points. Now I'm seeing that my point of intersection is right here. And so step 3 is going to be to determine this point of intersection. I see that we go over 3, up 2 for my point of intersection. And finally, as we mentioned, we want to make sure we check this to make sure that it works properly. So in the red equation, we have 2x, so 2 times 3 plus 2 should be equal to 8. 2 times 3 is 6, plus 2 does in fact equal 8. So we are good there. For the blue equation, I'm going to check it down here. We have a negative of 3 plus 2 times my y of 2 should equal 1. Negative of 3 is negative 3 plus 4, which does in fact equal 1. So we are good to go, which means now we need to identify the system type, which, because it has one solution, this means that it is consistent and independent.